There are 6 goodie bags. Each goodie bag contains 3 eraser tops and 4 stickers. And so we're seeing here the contents of all 6 goodie bags. It says explain why each of the 2 expressions 6 times 3 plus 6 times 4 and 6 times 3 plus 4 describes the total number of items in the goodie bags and therefore why those 2 expressions are equal. So we know if we took this second expression that if we were to distribute the 6 inside the parentheses, we would get 6 times 3 plus 6 times 4. So it would give us this first expression. So this is demonstrating the distributive property. And I'm just going to start with the first expression here. So, if I did 6 times 3, where is that coming from? Well, I know there's 3 eraser tops, right? And where does the 6 come from? It comes from there's 6 goodie bags. So wherever I have some room here, I'm going to squeeze this in. So I could say I have 6 goodie bags times 3 eraser tops per bag. And then what about the 6 times 4? So the 6 times 4 would be still the 6 goodie bags, but now it's the 4 stickers, right? So I'm going to add to that 6 goodie bags times 4 stickers per bag. So if I were to work through this expression, 6 times 3 plus 6 times 4, I would do my multiplication before I would do my addition, following order of operations. So I would do 6 times 3. So 6 goodie bags times 3 eraser tops per bag would give me 18. 18 what? Well, the bag part essentially cancels, and this is just eraser tops, right? So 18 eraser tops. So this is telling me that there's a total of 18 erasers among all 6 bags. And then I would add to that. So if I take 6 goodie bags times 4 stickers per bag, then that gives me 24 stickers. And then from there, I could add those together, right? Once I know how many total erasers there are and how many total stickers there are, I would add those together. And in this case, I'd find that that means there are 42 items. So with this one, the 6 times 3 plus 6 times 4, this one is calculating the total erasers and the total stickers and then adding them. So that's one way to do it, but then look at the other expression here. So the second expression, or the left side of my equation here. So if I do 6 times 3 plus 4 without distributing the 6, then I would actually follow the order of operations and do what's inside the parentheses first. So this would be like saying I have 6 goodie bags, and then I'm going to multiply that by, in parentheses, what I'm doing is adding the 3 eraser tops plus the 4 stickers. Now that's not a total, right? That's 3 eraser tops and 4 stickers per bag, right? So if I do what's inside the parentheses first, 3 eraser tops plus 4 stickers would be 7 items. And again, that's per goodie bag. So then once I find how many items there are in each bag, right? So I took the 3 and added to the 4, and I get that there are 7 items. Then I would multiply by the fact that there are 6 of these bags. And so 6 times 7 would give me 42 total items. So I still get 42 items either way, right? It's just this is a different way of doing it. So if I do 6 times 3 plus 4 and the 3 plus 4s in parentheses, doing it that way is actually adding first. So it adds the items and then multiplies by the number of bags. So it makes sense to do it either way. It's just two different ways of finding the total without actually individually counting every single item. And so we get the same answer either way. So we could say, both calculate the total number of items. So they equal each other. And that's the whole idea, right? So this is demonstrating the distributive property.